The unification of quantum mechanics and general relativity has long been considered the holy grail of physics, a single framework that explains both the microscopic world of particles and the macroscopic structure of spacetime. Despite decades of effort, these two pillars of modern physics remain mathematically incompatible. In this video, we propose a novel hypothesis, a vibrational geometric grid, an infinite multidimensional structure that underpins both spacetime and quantum phenomena. This grid acts as the interface between the quantum and the gravitational realms, offering a unified theory that links the smallest quantum fluctuations to the largest cosmic structures. More than just a physical framework, this grid integrates consciousness as an active participant, shaping reality through vibrations. By connecting principles of quantum mechanics, general relativity, and the nature of consciousness, this model bridges the gaps between the forces of the universe, redefining our understanding of reality as a unified dynamic and vibrational whole. First, the geometric grid, a new foundation for spacetime. 1. The structure of spacetime. Einstein's general relativity describes spacetime as a malleable fabric that curves in response to mass and energy. Yet, recent advances in quantum gravity suggest spacetime itself may emerge from a deeper, more fundamental structure. The geometric grid proposed here aligns with these ideas, positioning a foundational network of interconnected nodes. Fractal nature of spacetime. Research into quantum spacetime indicates that its structure exhibits fractal properties, particularly at Planck scale distances. This fractal nature mirrors the grid's repeating patterns of spheres and tubes, creating a self-similar framework across scales. Quantum geometry and loop quantum gravity, LQG. In LQG, spacetime is modeled as a lattice of discrete geometric units called spin networks. These networks resonate strongly with the idea of a vibrational grid that connects quantum and macroscopic phenomena. 2. Vibrations as the language of reality. The grid is not static, it vibrates. These vibrations encode the laws of physics and govern the interactions of matter and energy. This concept builds on well-established theories. String theory as vibrational physics. String theory postulates that particles are tiny vibrating strings, whose frequencies determine their properties. Our hypothesis extends this principle, proposing that spacetime itself vibrates as a medium, influencing everything from quantum behavior to gravitational curvature. Gravitational waves. Observed ripples in spacetime caused by massive events such as black hole mergers demonstrate that spacetime is not merely a passive backdrop, but a dynamic and vibrational entity. Second, bridging quantum mechanics and general relativity. 1. Particle-wave duality in the vibrational grid. One of quantum mechanics' key features, the wave-particle duality, reveals that particles exhibit both localized and distributed behaviors within the grid framework. Quantum fields as vibrations of the grid. Quantum particles are not independent entities, but localized vibrations in a broader field, echoing the concept of the grid as a vibrating medium. This idea resonates with quantum field theory, where particles arise from excitations in underlying fields. The holographic principle. The research suggests that the universe may function as a hologram, where information encoded on a 2D surface governs 3D reality. The grid offers a physical interpretation of this principle, with its vibrations encoding and projecting quantum states into spacetime. 2. Unifying gravity and quantum interactions. The primary challenge in uniting quantum mechanics with general relativity lies in reconciling gravity, described as spacetime curvature, with the probabilistic behavior of particles. The grid serves as a bridge, quantum gravity and emergent spacetime. Theories such as causal dynamical triangulation, CDT, suggest that spacetime emerges from quantum interactions. Similarly, the grid's vibrations create the framework for gravity, making it an emergent phenomena tied to quantum resonance. Gravitational waves as quantum ripples. Just as quantum fields produce particles interactions, the grid's vibrations could produce both gravitational waves and quantum effects, linking the curvature of spacetime to the probabilistic nature of quantum mechanics. Third, quantum entanglement and the geometric grid. Quantum entanglement, where particles remain instantaneously connected regardless of distance, challenges classical notions of locality. In the grid model, non-locality as resonance. Entangled particles are connected through the grid's vibrations, which operate on a level deeper than space-time. This resonance explains the instantaneous exchange of information observed in experiments. Pilot wave theory and hidden variables. Bohemian mechanics describes particles as guided by an unseen pilot wave. The grid could serve as this wave, mediating entanglement through its vibrational patterns. Fourth, consciousness and the vibrational grid. 1. Consciousness as a participant in reality. Consciousness is often treated as separate from physical phenomena, but emerging theories suggest it may play a fundamental role in shaping reality. Quantum biology and consciousness. Studies on microtubules in neurons. Hamroff and Penrose's theory proposed that quantum processes underlie consciousness. These processes could resonate with the grid, positioning consciousness as an active participant in the vibrational framework. Neural oscillations. Brainwaves operate at specific frequencies, suggests that human consciousness interacts with external vibrations. This aligns with the idea that the grid enables communication between consciousness and the physical world. 2. Free will and multiversal navigation. Consciousness in this model navigates the geometric grid, choosing pathways and shaping reality. Quantum decision-making. The probabilistic nature of quantum mechanics allows for multiple potential outcomes. Free will may arise from consciousness selecting pathways within the grid's vibrational landscape. Fifth, the multiverse interconnected layers of reality. The multiverse concept is gaining traction in theoretical physics, particularly in string theory and quantum cosmology. Within the grid framework, vibrations as universal signatures. Each universe has its own vibrational frequency, defined by its unique physical constants. These frequencies are interconnected through the grid, allowing potential interaction between universes, cross-universal resonance. Vibrations from one universe could influence another, creating a dynamic multiverse where boundaries are fluid rather than fixed. This explains phenomena such as quantum tunneling and virtual particles, which may result from inter-universal interactions. Conclusion: the unified vibrational framework of reality. The geometric grid proposed here offers a bold, unifying vision of reality, bridging the principles of quantum mechanics and general relativity. By framing space-time, quantum phenomena, and consciousness as interconnected vibrations, the model transcends traditional boundaries between physics and metaphysics. This framework challenges us to rethink the universe, not as a collection of separate phenomena, but as a cohesive geometric symphony. Space-time, particles, and galaxies are not isolated entities, but expressions of a deeper vibrational order. Consciousness, far from being an observer, is both a composer and performer in this cosmic symphony, shaping reality through its interactions with the grid. This hypothesis invites scientists and thinkers alike to explore the vibrational nature of existence, uniting the micro and the macro, the physical and the conscious. Through this lens, the universe becomes not just a place of existence, but a dynamic, interconnected dance, a resonating masterpiece that we as conscious beings help to co-create.